Hey guys, all right, now we are going to, you just did a ton of practice on delta math, hopefully, and are really good with taking the derivative using the limit process, whether that be through evaluating the limit using the alternate form of the derivative, or actually finding the actual derivative using the definition of the derivative. So now you get to do the shortcuts. So obviously there's some patterns that started to form, and I bet some of you guys started to figure those out as you were going through, especially with polynomial functions. You may have noticed that every time you took the derivative using the limit process, if you compared the original f of x function with f prime of x, your derivative, you may have noticed some patterns starting to form. And I believe we're going to talk about those a little bit on Wednesday as well, or I guess you guys are watching this after, whatever. So what I need you to do is open up your notes. You should have hopefully a notebook. I can't see you, but I'm hoping you all have a notebook, and I want you to open up a fresh, clean page for notes. And at the top of that page, I want you to please write rules of differentiation. And I want you to leave we're going to record some notes today. And then we're going to have some other notes that are going to be added to this page. And then to the back of this page, we're going to have another set of notes in another class. So what I would prefer for you to do, I know some of you guys like to have like your notes and then the homework that follows immediately after. If you could just for this section, leave the rest of this page blank after we fill in what we fill in today, because I have some other notes that are going to go on this page that'll just be really convenient if everything that you need for your rules of differentiation and your rules for derivatives of transcendental functions is all on the same page front and back. It just makes it really easy when we're studying as the AP test approaches, and for you when you're doing your homework to have all of that just in one space. So again, you're writing at the top of this page, rules of differentiation, and we're going to go through the first set of rules, and then again, please leave the rest of this page blank as well as the back of this page blank, and then you can do your own thing from there. So we're going to talk about 4 rules today. Our first rule is the constant rule. And this says that if I'm taking the derivative, that's what this T stands for, of some function with respect to x, of some constant c, so a constant may be like 5, 8, 10, some value that's not dependent on a variable, we're always going to get 0 out. And this makes sense, right? And you don't need to draw this part, but if you have a graph and the function is just a straight line like this, that straight, but it's a straight vertical line. So let's say this is the equation y equals 1. The derivative of this function is going to be the slope of the tangent line, or is going to represent the slope of the tangent line at every point, right? Well, at every single point, the slope of this line is 0. So our derivative of a constant is just 0. All right. Our next one is our power rule. Ooh, that's not how you spell power. And this is the one that you guys may have figured out. So this one says that if we take the derivative with respect to x of a polynomial function, so in this case, we're just going to do a monomial, x to the n power, it's always going to be the case that the n bumps to the front, and we multiply that by x to the n subtract 1. For example, if you're taking the derivative of x cubed, we're going to take this exponent and bump it to the front. So that's 3, keep the x, and then 3 subtract 1 is 2, so it will be 3x squared. So notice it goes down a degree. Our next one is the constant multiple rule. And this just says that if I'm taking the derivative of some function, let's say c, so some constant multiplied by some function, f of x, that c is just going to stay on the outside. So it's the same thing as having c times d dx of f of x, which would be c times f prime of x, whatever the derivative of that function is. So for example, if you have the derivative of 3x squared, we're going to do, it's the same as doing 3 times the derivative of x squared. So that would be 3 times, we're going to bump the 2 to the front, x, just decrease this by 1, so just 2x, and we would end up with 6x as our answer. So I don't go through this whole process every single time, but I just wanted to specify or show you guys. What I would generally do is bump the 2 to the front and say, okay, I have 2 times 3, and then decrease by 1. So I have 2 times 3, which is 6, and then x. The last one is the sum and difference. So if I have d dx of two functions that are either being added or subtracted, what's great about derivatives is that with a sum and difference, you can just take the derivative of them individually and then add or subtract them together. Now I want to take a moment to look at what's not here. So notice there's nothing here about products when we multiply two functions, and there's nothing here about division or quotients when we divide two products. So those are going to have their own rules, and we're going to add them onto this page so that we have them to look back at. But just keep in mind that if you have a product or if you have a quotient, you can't just take you won't just be able to take the derivative individually and kind of just mash them together like you can with the sum and difference. And we'll see some examples of that and what we need to do in those instances. So let's take a look. So when you're taking the derivative, our first example is going to be f of x equals 2 over x squared subtract 4x cubed. We need to be able to rewrite things in a smart way. So this is where our study from pre-calculus on polynomial functions as well as rational functions and exponents is really, really important. So I'm going to go ahead and rewrite this function in a form that's a little bit more workable before I take the derivative. So notice that I have an x squared in the denominator. That's the same as having f of x equal to 2 times x to the negative 2, subtract 4x cubed. So again, because I have an x squared in the denominator, that's the same as having an x to the negative second power in the numerator. And now because it's written like this, it's a lot easier to take the derivative. So now I'm going to say f prime of x equals, so I have an exponent of negative 2. So that's going to be multiplied by this 2. So that gives me negative 4x. I'm going to decrease this exponent by 1. So that gives me a negative 3. Subtract. Now again, I'm going to do 3. I'm going to bump it to the front and multiply. So 3 times 4 is 12. And then decrease by 1, I get x squared. As my final step, I want all of my exponents to be positive. So I'm just going to rewrite this as negative 4 over x cubed subtract 12x squared. And that's the derivative of f of x. Notice that these two monomials, or these two terms, were separated by addition and subtraction. So it was totally fine that I went ahead and just took the derivative of each of those terms separately. We can do that with addition and subtraction. All right, for this next one, notice I don't have addition and subtraction. In this case, I have division. And what I told you is that we can absolutely not take the derivative of the numerator, take the derivative of the denominator, and then just divide those two derivatives. That's not an option. But what we can do here, since we don't have a quotient rule, is rewrite this in a more manageable way. So I'm going to go ahead, and because each of these terms is divisible by x, I'm going to go ahead and divide each of these terms by x. It's like using the distributive property, but with division. So I'm going to rewrite f of x as this is, I'm going to really kind of spell this out right now to make sure we're good. 3 times x to the 4th divided by x, subtract 3x squared divided by x, subtract 2x divided by x. So that's just another way to write what we have up there. And now what I'm going to do is cancel some things out. So I have an x in the denominator. That's going to decrease this to an exponent of 3. That will decrease this to an exponent of 1, and that will just completely get rid of that x term. So now what I'll be taking the derivative of is just 3x to the 3rd, subtract 3x, subtract 2. So now f prime of x, I get 3 times 3 is 9. I decrease 9x, decrease this by 1, that gives me 9x squared, subtract. Now, this has an exponent of 1. 3 times 1 is just 3. And then I subtract 1, I get x to the 0. Well, x to the 0 is just 1, so I can just write 3. And then we learned from our constant rule that the derivative of a constant like -2 is 0, so this just goes away. So f prime of x ends up being 9x squared subtract 3. All right, this next one, notice I have a binomial times a binomial times a binomial. So if I had a product rule, this would be a little bit challenging, but it would be a breeze, but I don't have a product rule yet. So I need to rewrite this in a more manageable fashion. So I'm going to go ahead and start by multiplying these two binomials out. And remember, this is something that we always get tripped up on for some reason. If you were multiplying 2 times 3 times 4, you would first multiply 2 times 3 and get 6. And then you would take that product and multiply it by 4 to get 24. We're going to do the same thing here. So I'm going to start off by multiplying these two binomials. So I have f of x equal to x squared plus 5x plus 6. You'll get the same thing once you combine those like terms, the 3x and the 2x. And then I'm going to do the same thing here. So I have x squared, and I have to kind of draw this one out. I get 2x cubed plus x squared. So I know I did that. I'm good. Now I'm doing this next one. 5x times 2x gives me a 10x squared plus 5x. And then this gives me a 12x plus 6. I'm going to combine any like terms that I have. So I have 2x cubed plus 11x squared plus 17x plus 6. And now I'm just going to go back and double check. I had a 5x, I had a 6. Awesome. So this is what my f of x is. So now that I have that all multiplied out, I can take the derivative. So f prime of x, which is another way of saying the derivative of f of x, is going to be 6x squared plus 22x plus 17. And this derivative of 6 is just 0, so that's the end. All right, next up, notice I have another situation. I have a quotient. I can't just take the derivative of a quotient. I have to do something else. So I'm going to go ahead and rewrite this a little bit differently. So I'm going to rewrite this as f of x equals x cubed over x to the 5th subtract 5x squared over x to the 5th. So that gives me, and I want all positive exponents. So what I'm doing here is I have x cubed, and then since this is the denominator, I'm subtracting 5. So whenever you subtract exponents with the same base. So this is x to the negative 2nd power, subtract 5x to the negative 3rd power. Some of you guys may have done 1 over x squared, subtract 5 over x cubed, and then gotten here. That's totally fine. Same, just a different process, but the same result. So this is f of x. I've now written it in a smart way to take the derivative. So now f prime of x is going to be equal to, I'm going to bump this to the front, negative 2x. I'm decreasing this exponent by 1, so it's becoming more negative. Negative 3 times a negative 5 is a positive 15, x to the negative 4th. My final step is to write this with all positive exponents. So I get f prime of x equal to negative 2 over x cubed plus 15 over x to the 4th. So that would be my final answer. All right, now notice we have some square roots and we have some rational exponents. So I'm going to rewrite these because I have a feeling you can't actually see them. So here we have f of x equal to 3x divided by the cube root of x squared. And over here we have f of x equal to a negative 4x to the 4th plus 2x to the 1/4. All right, so let's start over here. Oop, I forgot my cube root. We're good. Okay. So remember, I don't have a quotient rule, so I need to first start by rewriting this because I also don't have a rule for square roots, but I do have a power rule. And I know that I can write square roots with an exponent, with a rational exponent. So I'm going to start by rewriting this as 3x divided by x to the 2/3, because if I have an index of 3, it means my exponent stays 2 divided by 3. Now, notice I have an x to the first up here and x to the 2/3. This is the same as saying 3x. I'm going to, instead of using 1, I'm going to use a 3 over 3, so I can combine these a little bit, times x to the negative 2/3. And then remember, you can add these two. So we have 3 over 3 plus a negative 2 over 3. So I'm going to rewrite this f of x as 3x to the 1/3. That's what that function would simplify to. Now, f prime of x, I'm just going to follow my power rule. I'm going to do 1/3. I'm going to multiply it by 3. That gives me 1 times x. And then I'm subtracting 1, but I'm going to subtract a smart one. I'm going to subtract 3 over 3. So that gives me a negative 2/3. So my final result is 1 divided by, my exponent is 2, that's 3. So it's going to be the cube root of x squared. Over here, everything's already written out for us. So we can dive right into taking the derivative. I have a negative 16x cubed plus 2 times 1/4, which is 1/2 x. And then I'm going to subtract 1, but I'm going to subtract a smart 1. So I'm going to subtract 4 over 4. So negative 3/4. When I rewrite that, this stays here. Plus, I have a 1 in the numerator divided by 2, and now my exponent is 3 and my index is 4. So it's the 4th root of x cubed, and I'm done. That would be my derivative. This would be my derivative. All right, hopefully you've tried these ones out on your own. And I'm gonna go ahead now and do the solutions for you. So this first one is just the power rule. So we're doing f prime of x. You should have gotten 12x squared plus 4x subtract 7. For number, I'll go over to number 6. Over here, we're dividing, so we need to rewrite this in a different way first. So I'm going to rewrite this f of x as x subtract 3 plus 4 over x, which is the same as x subtract 3 plus 4x to the negative first power. When I take the derivative of this function, the derivative of x, my exponent is 1, so I just get 1. The derivative of a constant is 0, so that's gone. And then here I'm going to have a negative 4x to the negative second. So this is going to be equal to 1 subtract 4 over x squared. Right here, I'm going to rewrite this first. This is y equals x squared plus 9. When I take the derivative of this, we're just going to write this as y prime equals 2x. The derivative of 9 is 0. I bumped that 2 to the front and then dropped that down by 1. In order to take the derivative of this function, you need to first rewrite it. This is the same as x to the 2/3. And so now I'm going to go ahead and take the derivative of that. So I bump my exponent to the front. That's 2/3 x. I'm going to subtract 3 over 3. That leaves me with a negative 1/3. So then when I rewrite this, this gets moved to the denominator in order for it to have a positive exponent. So I have 2 divided by 3 times the cube root of x. Right here, we just have a straight polynomial function. So we get f prime of x equal to 15x to the 4th subtract 4x. And then lastly, here I need to multiply this out. But what I'm noticing is this is a subtract b times a plus b. So I spotted a difference of squares. So I know f of x is going to be 4x squared subtract 9. So f prime of x is equal to 8x. All right, The next thing we just need to talk about, and you don't really need to take notes on this per se, I just kind of wanted to mention it. We talked about a little bit last class, are these equations of tangent lines. So again, the equation of the tangent line is telling us what that linear function is for a tangent line at a given point. So let's say that I had some quadratic that looked like this, and I wanted to know the equation of the tangent line when x equals 5 right here. What I'm writing the equation of is this linear function that touches briefly when x equals 5, and so it's tangent to this function. But notice it's going to be a linear function, so it touches here, and its slope is going to be the derivative evaluated at x equals 5. So let's just look at a few examples, and then we'll go from there. So we're going to find the equation of the tangent line to the graph of g of x equal to, so g of x equals 2 divided by the 4th root of x cubed when x equals 1. So another way to find this is saying I'm finding g prime of 1. And so we used our alternate form of the derivative last week. But now we have an even shorter way. So what we're going to do here is the first step is going to be to determine the derivative. So I'm going to go ahead and say, well, g prime of x equals, well, I can't do that yet, right? So let me rewrite this in a way that makes more sense. I have g of x equals 2 over x to the 3/4, which is the same as 2x to the negative 3/4. So if I'm finding g prime of x, I'm going to bump that 3/4 to the front. So I have 2 times a negative 3/4 multiplied by x, and I'm subtracting 4 over 4, so negative 7 over 4. I'm going to cross cancel here. I have negative 3/2 times x to the negative 7/4, which is the same as saying negative 3 over 2 times the 4th root of x to the 7th. Well, remember from algebra 2 and maybe pre-calc as well, if I have a 4, if I'm taking the 4th root of x to the 7th, I can take one of those roots out. And all you do here is subtract. You can also see it here. You can rewrite x to the negative 7/4 as x to the negative 4/4 times x to the negative 3/4. So notice it takes out one root and you're left with an x cubed. So I'm just going to rewrite this for g prime of x as negative 3 over 2x to the 4th root of x cubed. And now it wants me to evaluate this function. So our next step is to evaluate at, in this case, x equals 1. So I'm going to go ahead and say g prime of 1 equals negative 3 divided by 2 times 1 times the 4th root of 1 cubed. Well, that gives me negative 3 over 2. So my answer, the slope, would be negative 3 over 2. But it's not asking for the slope, it's asking for the equation of the tangent line. So that means I need something in the form y subtract y1 equals m times m subtract x1. So notice I have here what x equals 1, but I don't know what the y value is. So I'm going to go ahead and erase this just so I have some more space. So right now we know that our slope, which is equal to g prime of 1, so the slope of my tangent line, did we get negative 3/2, I believe? That was 3/4, yep, negative 3/2. And now my third step is to determine what g of 1 is, because I need to know what that output is in order to write it into point slope form. So g of 1 is going to be 2 over the 4th root of 1 cubed, which is just 2. So I know the ordered pair that this graph intersects is 1, 2. So my final step is to write the equation of the tangent line. So we have y subtract 2 equals a negative 3/2 x subtract 1, and this would be my final answer. All right, next up, we're determining the values of x for which f of x equals 2, and I'm going to rewrite that function. F of x equals x to the fourth subtract 8x squared plus 2 has a horizontal tangent line. So think about a graph that has a horizontal tangent line. And if we have a horizontal tangent line, what's the slope of that line? The slope of that line would be 0. So what we're determining is, where does this function have a derivative equal to 0? At which x values does that occur? So my first step here is going to be to take my derivative. I'm going to say f prime of x equals 4x cubed subtract 16x. Now what I need to do is set that equal to 0. So I'm going to say, all right, I want to know where that has a horizontal tangent line. And now we just factor. So I'm going to take out a 4x because that's my greatest common factor. If I take a 4x out of this, I'm left with x squared. If I take a 4x out of this, I'm left with a negative 4. So now I have 0 equals 4x times, and this is the difference of squares, x subtract 2, x plus 2. So what I find out is that I have a horizontal tangent line when 4x equals 0 or x equals 0, when x subtract 2 equals 0 or x equals 2, and x plus 2 equals 0 or x equals a negative 2. So my answer would be x equal to negative 2, 0, and 2. At all those points, I have a horizontal tangent line. All right, on this next one, we're asking for what values of x will the slope of the tangent line be equal to, I believe it's negative 2. Yep. And then we want to find the equation line of h of x at this or these values. So we are starting again. We have h of x equal to 4 root x. We want to know at what values does h prime of x equal negative 2. So I'm going to start again by taking my derivative, but first I need to rewrite h of x in a more workable fashion. That's going to be x to the 1/2. So now h prime of x equals, I bump the 1/2 to the front, I get 2. I decrease this by 2 over 2, which is a negative 1/2. So I get 2 over the square root of x. Now I want to know when this derivative equals negative 2. So I'm going to say, all right, I want to know when 2 over root x equals negative 2. So I need to get that root x out of the denominator by multiplying by root x. I get 2 equal to negative 2 root x. Then I'm going to divide by a negative 2, and I get negative 1 equal to root x. I'm going to go ahead and square both sides to get that square root out of the way, and I get 1 equal to x. But let's just go back for a second here. If I put 1 into this function, am I going to get negative 2 out? No. So in this example, there are no values. For which h prime of x equals negative 2. And the reason for that, if we were to sketch this graph, this is a square root function. This function always has a positive slope. So there is no way for this to occur. So it's kind of, you can back that up graphically quite easily. All right, last but not least, I'm going to go through, we're going to write the equation of the tangent line for both of these. I believe you already took the derivative of at least that second one, but we can go ahead and do it again. So we're writing the equation of the tangent line, or we're writing the equation of the line that's tangent to this at x equals 4. So the first thing we need to do is find f prime of x. So I'm going to rewrite this as x to the 1/2 plus 3. So that's going to give me 1/2 x to the negative 1/2. That 3 goes away. So I just get 1 over 2 root x. Now I want to evaluate that at 4. So I have 1 over 2 root 4, which is 1/4. Then I'm going to come over here and figure out what is f of 4, because I need to know what the corresponding y value is. That's the square root of 4 plus 3, which just gives me 5. So now I have the point 4, 5, and I have my slope, which is 1/4. So I have y subtract 5 equals 1/4 x subtract 4. All right, for the next one, we're writing again the equation of the tangent line for this graph. So I need to start off by finding f prime of x, but first let's just see what f of x is. It's going to be x subtract 3 plus 4x to the negative 1. I believe we already did that in a different example. We have f prime of x is going to equal 1 subtract 4x to the negative second, or 1 subtract 4 over x squared. We're now going to evaluate this when x equals 1. So we get 1 subtract 4 over 1, which equals a negative 3. I also need to substitute 1 into this function. F of 1 is going to give me 1 subtract 3 plus 4. So that gives me a 2. So I know this is occurring at the point 1, 2. So I have y subtract 2 equals a negative 3, x subtract 1. And